We present a new domain-specific language for linear algebra. It's called ICLR. As a PhD student, we often need to evaluate a paper. We read the paper over and find the formula. For this example, we may first implement it by C++. During implementation, it's easy to create bugs that we may never notice. Later on, we may switch it to Python and need to re-implement the same formula again. In general, it's inconvenient to maintain the consistency here, especially when the formula itself has typos sometimes. We introduce ICLR, a language which looks like the formula. Instead of manual translation, ICLR can compile automatically to LaTeX for the paper, C++, Python, and other languages in the future. No one has to re-implement and re-debug a formula written in ICLR. We evaluated ICLR on a variety of examples from different papers, books, and online courses. For each example, we show the original formula, ICLR implementation, output code for eigen, NumPy, LaTeX, and the rendered LaTeX output. We also replaced handwritten code with code generated by ICLR for another 10 examples. For each case study, we showed the original formula, the original source code, ICLR implementation, and the modified source code with ICLR output. This is the code repository for the previous case study. It comes from the paper Instant Field-Aligned Meshes. We've already replaced the original function by the output function from ICLR, and it's called by the midpoint function. We can compile the code. It will generate an executable file. And if we open this application, then we can open the mesh. Then we continually to click the Solve button. And the next Solve button, it will generate the same result as the original source code. This is a GUI for ICLR. It has 4 panels. The left panel shows the source code of ICLR. We can compile the source code through the menu button. By default, it will output C++ with eigen in the middle panel. The right panel will show the rendered LaTeX output. The bottom panel shows the status of the compiler. If we switch the languages to Python with NumPy and compile that again, we'll see the Python code in the middle panel. Now let's try to add a new expression here. The GUI supports some conversions from ASCII input to Unicode. When we finish editing, we can use hotkey to recompile that again, so that the code will be updated in the middle panel and the right panel. If we switch back to C++ with eigen and recompile that again, we'll also see the updated C++ code here. We also support a version that runs completely in the web browser. It supports Firefox and Chrome. The layout is very similar as the desktop GUI. This is the panel for ICLR source code. It supports different key bindings. On the bottom, there are 3 output panels. When we click the Compile button, we will see the output languages soon. In addition, we include a MathJax result here, which is already rendered. ICLR is deliberately limited in scope, and we haven't supported tensors and automatic differentiation yet. In future, we plan to add new output languages, support more language features like control flow, and refine the intermediate representation for common usage. We imagine the paper of the future as a literate environment or notebook where formulas can run directly or saved as code for any number of programming environments.